Hi, this movie is on naming ionic compounds. And the first compound I have for you is CaI2. All the compounds that you will be given that are ionic compounds are always made up of two things. In this case, it's calcium and iodine. So you can notice if a compound is ionic or not by its formula. An ionic compound is always made up of a metal and a nonmetal, or anything with a polyatomic ion. So if it's made up of metals or nonmetals, you got to look on your periodic table. And if it's something with a polyatomic ion in it, you got to look in your table of polyatomic ions. So here we have CaI2. Ca, if you look on the periodic table, stands for calcium, and iodine is right here, and it says iodine. So let's go back to our working sheet here. So Ca is calcium. So the first element, which is always the metal, you keep the name as found on the periodic table, and it's just its normal name. And then we've got iodine. We're going to take iodine. We're going to take off the ending and add IDE. So it would be iodide, calcium iodide. Let's try another one like NaF. Okay, so we've got our metal and we have our non-metal. And if you look on your periodic table, you will see that the table tells you where the metals are on the left side of the staircase here, and the non-metals are on the right. So here we have Na. So Na is sodium. F is fluorine, but we take off the ending and we say fluoride. All right. Now, it can get a little bit more challenging if you have an element that is multivalent, and that means it makes more than one type of ion. So here we have Cu2O and we have CuO. So two different compounds, and you might think, hey, it's copper oxide. But let's look a little closer. So if you look at your periodic table and you find copper, you can see it comes in more than one flavor, or it makes two different types of ions. So how do you figure out which one it is? Look at what it's attached to. Oxygen, if you check out oxygen on the periodic table, here it is over here, it makes an ion with a -2 charge. So oxygen is -2. Now copper, there's two of them. Copper can be +1 or copper can be +2. But since we have two coppers, I would choose the copper +1, because if I have two copper +1s, that will make a net positive charge of +2, which will balance out my one oxygen, which has a charge of -2. So the name of this compound would be copper 1 oxide. So use Roman numerals to say which ion it is. Here we have CuO. We know that oxygen has a -2 charge. Copper can be +1 or +2. We only have one copper, which has got to balance out the -2 charge. So it must be copper +2. Copper +2 and oxygen with a -2 would make a compound with no net charge. So this compound is called copper 2 oxide. That one was they're not always that hard. If you have something like FeCl3, if you look on the periodic table, lots of times when it's a transition element, the element will be multivalent. So here's iron, comes in +2 and +3. And we want to figure out which one it is. You can do the reverse crisscross rule, where the 3 goes with the iron. There's no number here, but you assume it's a 1. So we would say that the 3 goes with the iron, so it's the +3 charge, and the 1, which we don't write, would go with the chlorine. Now the first element is a metal, and it always makes a positive ion. And the secondary element is always a nonmetal, and it makes a negative ion. So that's the reverse crisscross rule. So this substance would be called, iron 3 chloride. Okay. Okay, and that also it works out this way. You have 1 iron, which is plus 3. Well, let's say we don't know what the charge is. So 1 iron, it's Fe. We don't know if it's plus 2 or plus 3. We know that there's 3 chlorines, and chlorine always is -1. So the total negative charge is -3. We only have 1 iron here. So which one do we pick? The Fe plus 3. So it's iron 3 chloride. Before we finish off, I want to talk about polyatomic ions. So let's say you have a compound like this, MgSO4. Now it's got more than 2 capital letters, more than 2 capital letters. So in that case, you know that you have a polyatomic ion in there. Polyatomic ion. And if you have a polyatomic ion in there, you have to go to your polyatomic ion table, which looks like this one here. And it's called polyatomic ion table. Can I scroll up? There we go. A lot of people miss this one here. There is one positive polyatomic ion, ammonium, right here. So we were looking at sulfate. Be careful, there's a sulfite and a sulfate. They're a little bit different. There's a 3 here and a 4 there. So sulfate and sulfite. So let's go back. It's MgSO4. So Mg is magnesium, and SO4 is sulfate. If it comes from the table of polyatomic ions, you don't change the ending to IDE. Okay? Don't be nervous if you see something with brackets, SrNO32. That just means there's 2 nitrates and you have a strontium. Now you have more than 2 capital letters, capital S, capital N, capital O. So that means you have a polyatomic ion there. So let's go to the polyatomic ion table and look for the nitrate. Here it is. Be careful, it's not nitrate. They're very similar. So you want to get the right one. So this substance would be called strontium nitrate. You could get one that's even a little bit more complicated, like CuNO3 2. And remember, copper is multivalent, and so it comes in more than one flavor, meaning there's more than one type of ion. We know in this formula that there are 2 nitrates, which gives me a net charge of -2. Copper can be +1 or +2. There's only 1 copper here. So which one will balance out the negative charge? The copper 2. So this would be called copper 2 nitrate. The reverse crisscross rule would work in this case. It usually does, but not always. So the 2 goes here. So that's the copper +2. And the 1 is not written. It goes here, which is the -1. Remember, the first ion is always positive and the second ion is always negative. So hopefully that works. I'm going to try and turn this off now. Let's see how I do.